Greetings everyone. Today we are going to discuss ratios. We do have a note sheet, so make sure you access that on Google Classroom. First, let's go over a few definitions so we can understand the vocabulary we're going to start regularly using. The first vocabulary word is the word ratio. A ratio compares two numbers by division. A couple of ways you might see it written. I might compare 2 boys to 3 girls. Or maybe I'll compare 4 cars to 5 trucks. So we can write it with a fraction bar or a colon. Remember, if you need to pause to jot any definitions down, please do so. The next definition is a rate. A rate is a ratio that compares quantities measured in different units. Different units is the key phrase here, and one of the rates that you use every day is miles per hour. So for example, if I'm driving in town, that would be 25 miles, and we normally say per hour, but by saying that we mean per 1 hour. So notice I'm comparing 25 to 1, but they're different units. We're comparing miles and hours. Let's also expand that idea of rate to talk about a unit rate. A unit rate is a ratio that compares to 1 of something. So again, using the speed of a vehicle, if I'm going 45 miles, that's per 1 hour. So having this denominator of 1 is 1 of something. Another way to look at it might be if you are shopping for a turkey. When you shop for a turkey, you have a certain cost per 1 pound of meat. So we pay per 1 pound. Let's take a look at a few examples. This first example, we're going to create ratios just based on the shapes. Now the order matters. Stars comes first. I see 5 stars. And we're comparing it to squares. And I see 11 squares. You can write it as 5 colon 11, or you can leave it as a fraction 5 to 11. Let's try again. Squares is 11 to circles, which is 2. Stars are 5 compared to circles, which is 2. Circles to stars. This matters. We're using the same numbers, but the order changes. Stars to all figures. So stars is 5, and all figures means everything. If I add up all the figures, I have 18 figures. Squares to all figures. Well, I have 11 squares, and there are 18 figures total. So when writing a ratio, you want to write it in the order that is asked. Let's take a look at another example. Let's say there's 30 students in a class, and 16 of those students are boys. Well, first of all, if I'm going to compare boys and girls, I need to figure out how many girls are there. Well, if there's 30 students and I subtract 16 boys, I'd be left with 14 girls. So the numbers aren't always given to you. Sometimes you need to calculate them first. Let's write some ratios. Girls to boys, 14 girls compared to 16 boys. Again, you can write it either way. Boys to girls, we just flip the order of our values. Girls to all students, 14 girls compared to all students, which is 30. Boys to all students, there's 16 boys compared to all students. Now let's talk a little more about unit rate. So on this example, if you would please add that phrase to show. So if you get stuck on a unit rate question, you know to come to example 3. So we're shopping for t-shirts and we want to know which store offers the best deal. So we're going to find the unit rate, which means I want to know how much one t-shirt costs, one t-shirt. So we're going to create a ratio. If store A costs $25 for 2 shirts, right? And I want to know how much one shirt costs. How do you think I'm going to do that? Well, look at the fraction. That ratio created a division. And if I divide 25 by 2, I get 12.5. And that's a good money number, right? That makes sense. $12.50 per shirt. Let's try it again. At store B, it costs $45 for 4 shirts. And I want to find out how much one shirt costs. I want the unit rate. So I'm going to treat this ratio as a division problem. 45 divided by 4 gets me 11.25. Let's try another one. At store C, it costs $30 for 3 shirts. And I want to know how much one shirt costs. So I'm going to take 30 divided by 3, which is $10. See how those ratios are written next to each other and they're comparable? All right. Now, we need to go back and actually answer the question. The question was, which store is the best deal? Meaning, which t-shirt's the cheapest? And if I take a look, store C only costs $10 a shirt. So that is going to be my best deal. All right, let's take a look at one more example. Now, the previous example is a little bit easier since it was written as a table. And this one is a few sentences. But we can turn this information into tables if needed. So for example, the first statement is talking about Trisha. And it says, Trisha ran 10 kilometers in 2.5 hours. So here's my rate, right? Now our goal again is we want to find out who's the fastest, so we need to create a unit rate. So a unit is a value of 1. So I want to know how many kilometers did she run in 1 hour. So we're going to again divide. We're going to take 10 kilometers divided by 2.5, and that means she ran 4 kilometers in 1 hour. Let's try it again for our next runner, Jason. Jason ran 7.5 kilometers in 2 hours. I want to know what his unit rate is per 1 hour. If I take 7.5 and I divide by 2, his unit rate is 3.75 kilometers every 1 hour. Let's go once more. This time we're going to talk about Olga. Olga currently ran 9.5 kilometers in 2.25 hours. We want to find her unit rate. How fast did she run per 1 hour? Take 9.5 and divide by 2.25. That would be about 4.2. Now, we're going to end up with some decimals in this unit, and so sometimes you're going to have to round, all right? 4.2, repeating, we can just round it to 4.2. Now, let's take a look. Our question that we're trying to figure out is who was the fastest? Who ran the furthest in 1 hour? In 1 hour, Olga ran 4.2 kilometers. She ran further. So she is the faster runner. All right, make sure that you check out Google Classroom to see what your task is at hand. Remember that idea that a unit rate will help me answer a lot of questions, so I need to figure out what that 1 unit is. As always, check PowerSchool. Let me know if you have any questions, and until next time, have a good one.